Hello, I'm David Mugisha, and I'm with
Baba's Elizabeth Shally, and we are here to talk about our problem, Crime Watch.
okay. So the domain we are handling is under law enforcement, and we are mainly focusing on predicting crime in given locations. So our main problem that we are looking at is actually predicting crime prediction, and we are specifically handling theft and burglary. Any other crime is not considered in a project.
So to talk about the AI accountability, this accountability is basically making sure that your artificial intelligence model, the machine learning model, conforms to certain rules and regulations that are put there. So we have different rules and regulations in terms of security that are in different countries. For this case, we are going to consider those in Uganda in terms of AI development, and also we are going to consider those regulations that are international. Then AI accountability, to make sure your AI is accountable, it should be interpretable. So this means that someone can explain how the AI came to a final decision to say that in this case, this area has a lot of crime, or a lot of burglary happens in this particular area. To also ensure AI accountability, we the developers ought to keep documentation of everything from the data cleaning stage to when you deploy the AI. So you ought to keep documentation of how you're doing everything, and this also brings in the aspect of which human being is responsible for making a decision at every stage. So your AI should show which human being is responsible for taking a decision. I can give an example of after our AI has predicted that there is crime in this particular area, and a human being who is using it is the final person to make a decision that, you know what, I can avoid this area, or I can continue go to this area but be cautious of maybe my property or up my security. Yeah, so something like that. That's what I can say about AI accountability.
Okay, so the project scope is mainly focusing on, like I said, on the crime, which is theft and burglary, and any other crime is not considered at this point. And also, our focus is mainly on Uganda as a population, and that's where our starting point is. We're only looking at Uganda. So one of the things that we cannot ignore is the population growth that is moving so fast. If you look at the population in Uganda back in 1992, which was around 18 million, and now it is approximately 48 million. Yeah, what that means is that the growing number of people comes with a lot of problems, including crimes. So the increase of crime, if you look at theft, if you look at the police report, crime is increasing at the same time. Now that you realize that there is need to find a solution of curbing crimes, and since there have been an increase in the technology, police has a way of capturing data. Now we can use that data and analyze it clearly and come up with accurate predictions to understand and be able to analyze crime and accurately predict when a theft or a robbery will happen. That is what we intend to address.
So the research questions. So since we are trying to solve the problem of burglary, so that we want to know how often burglary happens, and so that people get to know how to solve it and how to avoid it. So one of our research questions: how often is burglary committed in densely populated areas compared to sparsely populated areas? We do have a hypothesis of, in Uganda, when you look at the densely populated areas, they are mostly composed of people, of very many people who earn a low income. So there are very many there, and that means that there is a high crime rate, because these people do not get as much as you think they would get to sustain their lives. So that is an hypothesis that we want to prove. Is it true or is it false? And also we want to know places that are sparsely populated. We normally call them the rich areas. For example, Muyenga, they are they are not very much densely populated. They will have a lot of space. Most people live in their gates in their houses. So in these areas, is there a lot of burglary or not? So our assumption is there is no burglary. If it's there, it's a very low rate. So we want to prove, is it really true or not? So those are the hypotheses that we want to look at, and also our research questions are in that line.
Okay, so one of the main objectives we want to address is being able to, our model should be able to predict burglary in an area. So if looking at using that data, the data about crime and criminals that we are going to analyze, we should be able to predict when a burglary is most likely to happen. And that, not only that, but also being able to predict the likelihood of the crime to resurface. One of the things that are a fact is that crime is not evenly distributed. If you look at the criminal records, you realize that especially burglary and theft, there's a tendency of crime like theft or burglary happening in specific communities. So there's a higher chance, if a crime was done in a given community, it will be done again. So we want to have a model that can accurately predict when that crime will happen again, what's the possibility or probability of it resurfacing again in the given household. So that's what we want to address.
So we chose a data set, but this from Kego. But this data set was the data was collected from the US, in the different communities of US. It basically consists of the demographics of the different people from which the data was collected, the communities from which the data was collected. We have the different crimes committed in those communities. We do have the rate at which these crimes are committed in those communities. We do have the location, and yeah, that's what we are going to look at. We shall do cleaning of the data and remove some fields or some features that we are not going to consider in our model, like race, which we shall remove, and crime according to race, we shall also remove that, since we are not going to consider it in our model. So when we come to the proposed AI methodology, this is AI methodology. It's basically like the techniques that we are going to use to teach our machine learning model to be able to predict a burglary happening in a particular area. So we have different algorithms that we are going to consider. But first, in the methodology, the first thing we shall do, we've already identified our data set. So we are going to carry out pre-processing. Pre-processing is basically, we are going to download our data set in a .csv file, since it comes in a good format. And then we are going to clean the data, like I had explained earlier. We are going to clean the data so that we remove the data that we are not going to use, the different features that we are not going to use. And then we are going to use the decision trees. So decision trees is an interpretability methodology, AI methodology, in a way that it's easy to understand. It shows us from the beginning to the end of how the process was executed until when we reach a final decision. And then we shall use the regression. We shall use SVM, which is support vector method. We shall always, due to time, I'm not going to really explain everything, but yes, that is our presentation.
Okay, so in a nutshell, these are some of our references, but mainly that's a breakdown of what we are in planning to solve using machine learning. Stay blessed.